Hi everyone! Jordan here from Digital Owl. In this video, I will share with you my workflow in graphing a line in the form of a linear equation in two variables on the rectangular coordinate system. Okay, commence. Now, the rectangular coordinate system is also called the XY plane or the coordinate plane. The main horizontal line is what we call the x-axis, and the main vertical line is what we call the y-axis. Now, upon the intersection of these two axes, it formed four areas called quadrants. So, this part here is the quadrant 1. We have the area of quadrant 2. This is the territory of the quadrant 3 and the area of quadrant 4. Now, each unique location in the coordinate plane is defined by an ordered pair like this one. This exact location here, this red dot here, is defined by the ordered pair 3, 6, where 3 is what we call the abscissa and 6 is what we call the ordinate. Okay, so for this one, this point here, the abscissa is -4, the ordinate is 1. Okay. Now, Cartesian coordinates are also essential tools for most applied disciplines that deal with geometry, including astronomy, physics, engineering, and many more. They are the most common coordinate system used in computer graphics, computer-aided geometric design, and other geometry-aided or geometry-related data processing. If a point is defined by its own ordered pair, a line is defined by its own equation. A linear equation in two variables to be more precise. Now, that kind of equation has a variety of forms, and the most well-known is what we call the slope-intercept form. In this form, also called the y form, the variable y is isolated on the left side of the equation, and this is the best form if you will graph this on the rectangular coordinate system. Now, let's have our first example, like this one. This is an example of a linear equation in two variables already in the slope-intercept form. As you can see here, the y is alone on the left side of the equation. Okay, so this is the y form. Now, for us to be able to graph this, we need to determine ordered pairs that is included in the equation. So, first step is to set a table of values. So, we have a table of values here, values for x. These are the values for x, and this will be the values for y. And then the technique here is we will assign a value for x and then solve later for the value of y. Now, moving on, what do you think should we use? What number should we use for the value of x? What do you think is the number which is easiest to solve or easiest to compute? And that is number 0. Okay, so what we're going to do is substitute the value 0 to the variable x. It will become like this. Y is equal to 3/4 multiplied by 0 plus 2. We still have that plus 2. And then, we all know that when we multiply any number to 0, the result is 0. So we have here 0, and then we still have that plus 2. And finally, 0 plus 2 is 2. Meaning, if the value of x is 0, its corresponding value of y is 2. Hence, we now have an ordered pair 0, 2, and its location is right there, 0, 2. That is the location of 0, 2. So, we're not done. We now move on to the next value of x. Now, the suggestion here is that since the coefficient of x, by the way, this is the slope of this linear equation in two variables. So, I will talk about slope on another video, or you can refer to other videos talking about slope. Now, this numerical coefficient of x is a fraction with a denominator of 4. So, the best numbers that we're going to use here for us to avoid fractions, let us avoid decimals. It is better to use whole numbers, okay, for easier graphing procedures or easier locating ordered pairs in the Cartesian plane. The best numbers here are multiples of that denominator. So as you can see, our denominator is 4. So the best numbers that we have to use or we need to use are multiples of 4. Okay, and the first multiple of 4 is of course 4. So we substitute the value of 4. So instead of 3/4 multiplied by 0 earlier, it becomes 3/4 multiplied by 4. And then we still have that plus 2. Now, what we're going to do here is the ordinary manner, the regular manner of multiplying fractions to whole numbers is like this. 3 times 4 is 12. Then divided by 4, we have 3. Or I have a suggestion, do the division first because it is easier to divide first, like this one. So 4, start with 4, divided by 4 is 1. 1 times 3, the answer now is 3. So 3/4 multiplied by 4 is 3. And we still have that plus 2. Then finally, we have 5. Meaning, if the value of x is 4, the value of y is 5. And locating that in our Cartesian plane, there it is. There is our 4, 5. That is the location of the second ordered pair. So, the truth is, you can already graph your line. However, it is strongly suggested to have at least 3 ordered pairs. So, for you to confirm that your line is in the right direction. And then, so we tried 4. Let's try negative 4. Still, that is a multiple of 4, the denominator of the coefficient of x. And then moving on, so we replace x by that negative 4. And then remember, if we're going to multiply a positive to a negative, of course the result is automatically negative. And then we proceed to, you can do this 3 times 4 divided by 4, or you can do the other process that I mentioned earlier. 4 divided by 4 is 1, multiplied by 3 is 3. So therefore, the answer is negative 3. And negative 3, still we have that plus 2. Negative 3 plus 2 is negative 1. Therefore, if the value of x is negative 4, its corresponding value of y is negative 1. And then locate that on our Cartesian plane. There we have it, negative 4, negative 1. And finally, draw a line that passes through all those 3 ordered pairs or those 3 points. That now is the graph of y is equal to 3/4 x plus 2. Now, if you're interested in automating these kinds of problems, I have created a course entitled Linear Equation Graphing Support, or LEGS. There you will learn how to manipulate a software that I created that can instantly display the ordered pairs needed prior to graphing a line. You may find the link down below. Hey guys, before we continue, it would be nice if you'd give us a like, subscribe on this channel, and hit that notification bell for you to be prompted about future videos. Another form of a linear equation in 2 variables that you might encounter is the general form. In this form, the constant term is the one isolated on the right side of the equation. The a, or the numerical coefficient of x, is positive and all numbers are integers, meaning no fractions, radicals, or decimals. Now, in case you come across one that has decimals or fractions, there is a strategy to remove those, in which the value of the linear equation remains and you still observe the conditions of a general form. There might be a video out there that can teach you this, but if you can't find it, you can send me a comment and it'll be my pleasure to make one for you. Moving on, just like what I mentioned earlier, the slope-intercept form is the best form if we would like to graph a line on the Cartesian plane. So, in this example, 2x plus 5y is equal to 15, we will convert that into a y form, like this one. So, in conversion, it becomes y is equal to negative 2/5x minus 3. Again, there could be something out there, a guide or video that might help you with the rewriting equations. But if you think that I can help you with this, then type a message for me below and I could create a short one for you. Now that it has been converted, we just follow the approach that we used in the first example. We make a table of values for x and y. We assign numbers for x and then solve later for the value of y. So we start using the number 0, replace it with x in the slope-intercept form. So it becomes negative 2/5x multiplied by 0 minus 3. Then multiplying it to 0, it will result to 0. And then we still have that minus 3. 0 minus 3 now is negative 3. Therefore, if the value of x is 0, then the value of y is negative 3. And we can locate it here, right here. As you can see, that is 0, negative 3. And then since we are dealing with, again, with a fraction numerical coefficient for x, or that is the slope, as I mentioned earlier. So the denominator is 5. So it is really recommended to use values of x that are multiples of 5. So let's use number 5. So we replace the value of x with 5. So negative multiplied by positive, definitely the result will be negative. And then you can do this. 2 times 5 is 10, divided by 5 is 2. Or 5 divided by 5 is 1, multiplied by 2 we have 2. And then it will yield to negative 2. We still have that minus 3. Negative 2 minus 3 is negative 5, meaning if the value of x is 5, the value of y is negative 5. We can find it here, that is 5, negative 5. And for the third ordered pair, let's try using negative 5. Replace x with the negative 5, and then negative multiplied by negative, it will result to a positive number. And then I'd like to use the second technique. 5 divided by 5 is 1, multiplied by 2 is 2. And then we will have positive 2. We still have that minus 3. 2 minus 3 is negative 1. Then, meaning if the value of x is negative 1, the value of y is negative, if the value of x is negative 5, the value of y is negative 1. We can find it here, negative 5, negative 1. And lastly, draw a line passing through all those 3 points. And that is the graph of 2x plus 5y is equal to 15. The linear equation graphing support can also be manipulated even if the given equation is in the general form. No need to rewrite it into the slope-intercept form. And still, you can generate ordered pairs that will be used to graph your line. Okay. Alright, so this is it. This now concludes my video about my workflow in graphing a linear equation in 2 variables. I do hope that this was helpful, and then I am looking forward that you'll have an easier time solving problems like this. Okay, goodbye!